differentiate r of x equals ln of x plus 1 over x minus 2. Now, to differentiate this, we're going to have to use the chain rule because we've got a composition of functions, but we're also going to have to use the quotient rule when we differentiate the inside. But let's start with the outside. The derivative of ln of u is 1 over u, so this is going to be 1 over that fraction, x plus 1 over x minus 2, times the derivative of the inside, which is x plus 1 over x minus 2. So to do this derivative, we're going to need the quotient rule. Remember, the quotient rule is low d high, so x minus 2 times the derivative of the higher function. The derivative of x plus 1 is just 1, minus high d low. The higher function is x plus 1 times the derivative of the lower function. The derivative of x minus 2 is just 1, so not bad actually, all over low squared. So it's going to be x minus 2 squared. Now, if we look in the numerator, anything times 1 is itself, so we basically have x minus 2 minus the quantity x plus 1. I'm going to deal with this off to the side, just to avoid rewriting things too much. X minus 2 minus the quantity x plus 1. When we distribute that subtraction, it's going to give us x minus 2 minus x minus 1. And the x's are going to cancel, and negative 2 minus 1 is negative 3. So that whole numerator is going to be negative 3. Also, we know that if we take 1 and divide it by a fraction, it's the same as multiplying by the reciprocal, and anything times 1 is itself. So this is going to turn into the reciprocal of that fraction. It's going to turn into x minus 2 over x plus 1. And then we said this other fraction was going to be negative 3 over x minus 2 squared. And we can see there's one more thing that's going to cancel. The x minus 2 in the numerator is going to cancel with one of the factors of the x minus 2 in the denominator. And when we get rid of one of them, instead of having it be squared, we're just going to be left with one of those x minus 2's. So that x minus 2 stays, and so we end up with the fraction negative 3 over x plus 1 times x minus 2. You do not have to multiply all of that out in the bottom. We often like things staying in their factored form. And so this is what we get. It ends up being really nice in the end.